Hi everybody, today we're talking about how you can find the distance between 2 points. So here are some examples. You see some horizontal lines and some vertical lines. If you are given a horizontal or vertical line on a coordinate graph, you would simply figure out how many units those 2 points are away from each other. So for instance, the distance between P and Q would be 1, 2, and 3 units away from each other. Distance between J and K, 1, 2, 3, 4, 5 units away from each other. And for a vertical line, it would just be the same, except you would be going up and down. So the distance between S and R would be 1 and 2 units. Distance between M and L would be 1, 2, and 3 units. So on a coordinate graph, you would just count how many units they are away from each other. If you don't have a coordinate graph, you would still be able to figure out the distance pretty easily. If I were to give you the coordinate points for S and R, for instance, -2, 1, and -2, 3, you notice that they both lie on the x equals -2 line, and except one is at y equals 1 and the other is at y equals 3. The trick without a coordinate graph would be to subtract their difference in y values. So this is 3 minus 1, which will give you that 2. Similarly, for this point right here, P is at 1, 2, and Q is at 4, 2. They have the same y value. They both have a y equals 2. So you would perform the opposite, which is subtract their x values. So this would be 4 minus 1, which would equal to 3, because their other, whether it's an x or y value, is exactly the same. So you're trying to figure out how far away they are with their other x or y value. Now, this isn't very challenging, though, right? This is a pretty easy concept. What we do want to challenge you to think about is how you would figure out the distance between 2 points if they were a diagonal line, for example, where you can't necessarily count the units between them because they don't necessarily fall evenly on a unit. So we're going to take a look at this coordinate graph now. What do you notice? Well, what you probably notice is that there are 2 examples of diagonal lines that we now need to figure out the distance between. But then there are also some dotted lines there to show that you can make yourself a right triangle. And up until now, you've actually learned a lot about right triangles. We've learned about Pythagorean theorem. We've learned about rise over run, which also actually involves right triangles when you create your triangles. So you are equipped to figure out the distance between 2 points that make a diagonal line. What you can do is you can use the information you know on your graph when you make a right triangle, because when you make a right triangle, you do create 2 vertical or horizontal lines. So for AB, for instance, I have going from A to N, 1, 2, 3 units. And then going from N to B, it is 1, 2, 2 units. Same over here, 1, 2, 3, 4, 5 units. And over here, 1, 2, 3, 4, 5, 6 units. And just like that, I have the legs of my 2 right triangles, and I can utilize my Pythagorean theorem, a squared plus b squared equals c squared, to now figure out the c value, my hypotenuse, which is missing. But notice how in the Pythagorean theorem, it gives you the answer for c squared, right? So let's go ahead and figure out how we can change up this formula, this Pythagorean theorem formula. So I'm just getting my c value. Now, if you're saying to yourself, oh, what I can do is the opposite of the square, then you are correct. The opposite of the square is square root, right? So that would actually give you just the answer for c at the end. So to figure out the diagonal length, it would be the square root of whatever one of your legs is squared plus the other leg squared. And that'll get you your distance for that diagonal line. Okay, so we're going to use that information. And this is how mathematicians derived the distance formula. This is an actual formula, and it comes from our knowledge of Pythagorean theorem. And it states that the distance between 2 points, A, which has the coordinate points of x1, y1, and B, which has the coordinate points of x2, y2, is AB equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Go ahead and write this in your notebook. It may not make sense to you right now with the x1s and x2s, y1s and y2s, but we're going to go back and take a look at our previous examples and use this formula. So write this down in your notebook first. All right, so back to this. Okay, we're going to focus on our coordinate points now. Okay, so I'm going to rewrite that formula. Okay, so the distance formula says that it's the square root of x2 minus x1 squared plus the y's, okay? x2 minus x1 squared plus the same thing for the y's squared. All right, and then remember this utilizes, I'll use this one up here so that we have enough space. This is going to utilize our coordinate pairs. So once you master this formula, you actually don't even need your graph, which is the beauty of it. You just need their coordinate pairs, which, you can find from a problem, and then you wouldn't even need to do any counting. All right. So I have my coordinate pairs. Let's write those down. I have for B 4, 3, and for A 1, 1. Okay, and so that this formula makes sense, I'm going to label them. I'm going to call this one x1 and this one y1. So all that means is that it's the x and y value for my first point. And this one I'll call x2 and this one y2. It's just the x and y value for my second point. Now, could I have switched them around? Yeah, I totally could. It doesn't matter which one you call your first point or which one's your second point. Okay, it really doesn't matter. What I do want to do is actually switch it, because later on I have to take my x2 and minus my x1. And so just for the sake of me following the rules, I can get a positive answer, but even at the end it won't really matter. Okay, so let me show you what it would look like if I were to switch them. Okay, so let's call this one x2 and this one y2, this one x1 and this one y1. And then later on, once we get the answer, we'll switch it back and show you how it's exactly the same, but it really doesn't matter. Okay, now I'm going to actually use this equation. I need to figure out the square root of x2 minus x1. So my x2 is 4, my x1 is 1. 4 minus 1. Then I'm going to take that answer and square it. Plus my y2 value, which is 3, minus y1, which is 1. And I'm going to square that. Okay? So 4 minus 1 is 3. I'm going to square that later. Plus 3 minus 1 is 2, and I'll square that. Okay? So 3 times 3 is 9. 2 times 2 is 4. So then my final answer is whatever the square root of 4 plus 9 is, which is 13. That'll be my answer. Now, did I get 3 and 2 for my sides if I were to count it normally? Yeah, I would get 2 here. 1, 2, 3. And I would get 3 here. Okay? So this formula basically helps me figure out my 2 legs without graphing. And then it uses the Pythagorean theorem to then figure out the leg, or the hypotenuse, which is missing, which is square root of 13. Okay, and as promised, we're going to do it again, but we're going to show you that you're going to get the same answer even if you were to switch these guys around. Okay, so instead of calling the first one y1 and x1, we will call it x2 and y2. So we're just going to switch them around. Okay, use the same formula. You should get the same answer of square root of 13. All right, x2 minus x1. Now my x2 is 1 and my y1 or x1 is 4. So 1 minus 4. So you're basically switching them around. And then y2 minus y1, so that's 1 minus 3. Okay, so 1 minus 4 is negative 3 squared, plus 1 minus 3 is negative 2 squared. Ew, I don't like negative numbers. That's why I switched them in the first place. Okay, but if you don't, that's okay. Negative 3 times negative 3, guess what, is still a positive 9. Negative 2 times negative 2 is still a positive 4. So that square up there is going to make it so it doesn't really matter because you're still going to end up with the same answer and positive. 9 plus 4 is 13. It's a square root of 13. Still get the same answer. Did we need the graph at all? No, we did not. Okay, now if they provide you a picture with the graph, oh my gosh, utilize the graph, right? But if they don't provide you with the graph and they're just like, hey, I need to figure out the distance between these 2 points and I'm not providing you with a graph, this might be your best bet using the formula because then you don't have to take out graph paper and plot it out. You know, it just saves you some time if you remember this formula. Okay, so remember this is the formula for the distance between 2 points. It came from our Pythagorean theorem because it's basically saying c squared, that diagonal, is equal to a squared plus b squared, right? So then if we were just figure out c, it would be the square root of a squared plus b squared. So that's basically what that is. And then these guys, the x1, x2, y1, y2, is just, you know, taking your coordinate points and labeling them. You're subtracting them because that's how you figure out their distance, right? What's the difference between, what's the rise here? Well, my rise would be the difference between 1 and 3. And that's basically what I was counting, the difference. So that's why they subtract those. All right, let's do an example from our book then. Look at that. They don't give you a coordinate plane. So this is where our formula would be helpful. They're giving us A, B, and C. We need to find the lengths of AB, BC, and AC. Then we need to show that they actually lie on a straight line. Go ahead and pause the video and try it on your own first. All right, let's figure out AB. So that means I'm only using A and B. Let's make this x2 and y2, x1 and y1. We're following the equation, which says that it's x2 minus x1. Remember, it doesn't really matter the order, but you do want to make sure that it is the same, okay? So if you're doing x2 minus x1 here, make sure that it is also y2 minus y1. Don't mix it up like this and change the order, because you do want to count in the same order when you're figuring out their difference, okay? So if you're going to change it to 2 and 1 for the x, then make sure it's 2 and 1 for the y as well. All right, let's put our numbers in. x2 minus x1, so 8 minus 5 squared, plus y2 minus y1, so 6 minus 5 squared. So we have 3 squared plus 1 squared. So this answer would be 9 plus 1 squared, or sorry, 9 plus 1 square rooted. So AB is the square root of 10. I'll write that above there. Now we need to figure out BC. So let's go ahead and save some space here so that we don't have to do all that later. All right, B and C. Well, I already put this as x1, y1, so let's make this x2 and y2, okay? So BC, I have x2 minus x1, negative 4 minus 5, because I'm looking at just B and C. And then y2 is 2 minus 5. Ugh, I have some negative numbers, but that's okay. It's going to work out. Negative 4 minus 5 is negative 9. 2 minus 5 is negative 3. So 9 squared is, 9 times 9 is 81. 3 times 3 is 9. So this is 90, square root of 90. BC is square root of 90. All right, and then lastly, we have AC. So let me erase this so I can reuse it because it's the same formula. And the only problem here is they're both labeled x2 and y2. So let me go ahead and change one of them. Okay. Change this one to x1 and y1. All right. So we're just looking at A and C. All right, so I have x2 minus x1, 8 minus negative 4. Ooh, 8 minus negative 4. So that's going to become a 8 plus 4 because I have two minuses. And then my y2, 6 minus 2. Oh, that one's good. 8 plus 4 is 12. 6 minus 2 is 4. So 12 times 12, 144. And then 4 times 4 is 16. Let me just give me some more room here. 144 plus 16. All right, so that would be 160. Is that right? Let me double check. 144 plus 16. Yeah, 160. So square root of 160. All right, and lastly, we need to show that A, B, and C lie on a straight line. And I'm going to try and do as much as I can without a coordinate plane, okay? Because I really don't want to bust out a coordinate plane. It's going to waste so much time. So the more I can use of a logic, the better, okay? All right. So I have A, B, and C. Let's assume that they're on a straight line, okay? Let's assume A, B, and C are on a straight line. Well, if that were the case, then AB plus BC should equal to AC, right? So let's see if that's true. So again, square root of 10 plus square root of 90 should then add up and equal to AC, square root of 160. Now with square roots, it doesn't just work like, oh, 10 plus 90 is not equal to 160. It's not like that, right? Because we still have to square root them. So let's figure out the square root of 10 in our calculator. Square root of 10, that's really 3.2, okay? Square root of 90 is really 9.5-ish. It might be a little bit off because we are, rounding. And then what's square root of 160? 160 square rooted, 12.6. So is 3.2 plus 9.5 around 12.6? Yeah, it is, and we did round up. So I'm going to go ahead and say that because these two, AB plus BC, equals AC, that they are, yes, on a straight line. Boom. Didn't have to do any of this with a coordinate plane because I know my shortcuts. All right, let's try example 2 now. The vertices of triangle ABC are as follows. Find the lengths of AB, BC, and CA. Show that that triangle is a right angle triangle, so a right triangle. Then find the perimeter of triangle ABC, round it to 3 significant figures, and then find the area of triangle ABC. Ooh, that's a lot. And then I'm gonna challenge myself and not use a coordinate plane. Go ahead and pause the video, try it on your own first. All right, so to figure out AB, I need to use my formula, right? So it's going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so this is x1 and this is, ooh, you know what? I'm going to switch it around. I'm going to call this x2 because I know I'm going to have to subtract later and I don't like this order right now. All right, so I have x2, 2 minus negative 2. I know from before that I like those two minuses together because they become a plus, and then I can avoid negatives. Y2 minus y1, 3 minus 1. Oh, so much better than 1 minus 3. Square that, and so I get the square root of 4 squared plus 2 squared, which is really 16 plus 4, which is really square root of 20. So AB is the square root of 20. Let me put that over here. Okay, I need to find now BC. So let me erase so that I can utilize this space again. And I'm just looking at B to C now. So let me call this x2, y2. Okay, so x2 minus x1, so it's negative 1 minus negative 2, so that becomes a plus, those two negatives together. And then y2 minus y1, negative 1 minus 1. Okay, so I end up with negative 1 plus 2 is a positive 1, and then negative 1 minus 1 is a negative 2. 1 squared is 1, negative 2 squared is 4, so it's square root of 5. Okay, and the last one, I know it's going to be a square root answer, so that's why I'm putting that there. Let me erase my stuff. I'm figuring out CA now. Okay, C and A are both labeled the same, so I'm going to have to switch one of them around. And I'm going to want to try and decide on the best one to be subtracting. Yeah, let's make this one into a 1. X1 and Y1. So I'm figuring out CA. Just looking at C and A. Let's see, x2 minus x1. So 2 minus negative 1 becomes a 2 plus 1. And then 3, my y2 minus -1. 3 minus -1 becomes a plus. So this is 3 squared plus 4 squared. So that's 9 plus 16. And then, let me put parentheses there so it doesn't look like 32. 9 plus 16 is 25. Oh, and the square root of 25 is just 5. So, this is actually just 5. Okay. Show that triangle ABC is a right-angled triangle. I don't know about you, but I already see that it is, because I have a square root of 20, a square root of 5, and then my last answer was square root of 25. So hello, that's going to be easy to show. But let me show you what I'm talking about. If the equation, remember we're looking at part B now, show that it's a right angle triangle. If the equation is a squared plus b squared equals c squared, then hey, look at that. 20, square root of 20 squared plus square root of 5, because those are my a and b, I'm assuming, squared should equal to my 5, my answer, squared. Square root of 20 and my square cancel out. They're opposites of each other. So if you square a square root, you basically get the number itself. Here I'm squaring my square root, so I basically just have 5 at the end. Okay, and then 5 times 5 is 25. Does 20 plus 5 equal 25? Yeah, it does. They are a right, or they make up a right triangle. Now we got to find the perimeter, rounded to 3 significant figures. I really like this purple and blue together, so I'm going to stick with it. We're on C now, finding the perimeter. Remember, perimeter means that you're adding up all your sides, okay? So I just have to add up all my sides. Round to 3 significant figures. So let's first set it up. Square root of 20 is 4.47, let's say 2. Oh, they said 3 significant figures, so 3 figures. Square root of 20. 4.47. 3 significant figures plus my square root of 5. 2.2, let's say 4. 2.24 plus 5. Okay, so I just got to add those all up because that's what perimeter tells us to do. 4.47 plus 2.24 plus my 5. So the perimeter of this triangle, this right triangle, is 11.71. What is this? Units? They didn't really give us units, so we'll just say it's units. 3 significant figures, so our final answer is 11.7 units. That's our perimeter. And then lastly, they want us to find the area of triangle ABC. So area, that one requires us to think a little bit more about what's going on. So I'm going to actually draw this triangle out. Looking at D. Oops. Okay, so I have my triangle, which again is a right triangle. My hypotenuse was my 5, right? Because that was what my c squared was equal to, my c value. And then it doesn't really matter what's over here. Now the area of a triangle is equal to length times width divided by 2. Because normally for a rectangle, it would just be length times width, right? But a triangle is half of that. So that's why we're taking length multiplied by width, and then we still have to divide it by 2 to only figure out half of it. Okay, so I'm really just looking at my legs. So my area will be my length, -20, times my width, square root of 5, divide by 2. So square root of 20, again, I wish I wrote this down, 4.47 times my square root of 5, 2.24, and then we're going to have to then divide it by 2. Okay, so 4.47 times 2.24 divided by 2. They want it to the, no, they don't care. So yeah, that's kind of a 5. So that would be 5 units squared. So for the area, you don't need the hypotenuse because it's just the diagonal. You only need the length and the width, which are the legs.